When finding an inverse, we have a three-step method. The first step is to replace f of x with y and switch x and y. Then, step 2, solve for y, and step 3, replace the y with f inverse of x notation. But to find an inverse, you must first start with a function which is 1 to 1. Now x squared is a parabola. Minus 6 would move it down to negative 6, and the function would look something like this. The problem is, this function is not 1 to 1, and an inverse can only be found for a function that is 1 to 1, because imagine this failing the horizontal line test. If you were to reflect it over the line y equals x, it would result in a function that fails the vertical line test, and it would not be a function. So what I'm going to do is I'm choosing to restrict the domain of this to just this branch. These are called branches of the parabola. And I'm going to say, okay, for this problem, the domain is just x is greater than or equal to 0. This isn't something we really emphasized during the course this year, but because I am making a video and posting it on YouTube, I would like it to be mathematically correct. I don't suspect you'll have to do this on the exam. So let's go to the steps that I would expect you to show. First, you should replace f of x with y and switch the x and y. Now, let's solve for y. So I will add 6 to both sides, and I like to have my y on the left. So I'm going to come over here, and I'm going to take the square root of both sides, which will result in y equals plus or minus the square root of x plus 6. Now earlier I had told you that I was restricting the domain of the f of x function to x is greater than or equal to 0. Now if that means that the smallest x that I'm putting into this f of x function is 0, what would that mean about the value of the output of this? Well, if the smallest value I'm putting in for x is 0, 0 squared is 0, minus 6 is negative 6. So the smallest the output or the range would be is negative 6. When we find an inverse, we are in effect switching the x and y values, which means that if the domain of this original function is x is greater than or 0, that would be the range of my answer here. And if the range of this function is y is greater than or equal to negative 6, that would become the domain. Again, I don't think this is going to happen to you on the exam. I think they're going to give you something that's already 1 to 1. So I just wanted to be correct completely. This is something we're going to see in Common Core more next year, and you'll see in Pre-Calc next year. But for right now, these are the steps you really need to know. I've always loved algebra, and this is one of my more favorite procedures. This completing the square twice to create a circle's equation in what's known as center radius form. What we need to do is we need to get these x terms together, and let's leave a little space here for something that we're going to add to create a trinomial, and then let's get these y terms together, and I'm going to again leave a space here for something I'm going to add, and I clear the constant over to the other side. Now I added 2 values to the left, so I need to add those same 2 values to the right. The question is, what should those values be? Well, the way you figure that out is very cleverly. Some mathematician figured out that if you just take half of this and multiply it by itself, so half of 2 is 1, squared is 1, and half of 6 is 3, squared is 9. So I'm going to add the 1 and the 9 here. By doing so, you end up creating a trinomial that can be factored. Not only can it be factored, but the 2 factors are the same. These trinomials are special, and they have a name. They're called perfect square trinomials. The reason they're called perfect square trinomials is because the 2 factors end up being the same, which means you can write one of the factors squared, the other factor squared. Now over on the right here, I still have this this negative 3 plus 1 plus 9, and I'm going to end up getting, let's see here, I'll end up getting 7. That's not really important. It's important that I get the correct value there, but what's really interesting to me is this on the left-hand side, because if we wanted to, we could end up taking the square root of this because it's a perfect square. That's why it's called a perfect square trinomial. Anyway, we're really done at this point. This is the center radius form. Our center would be positive 1, negative 3, and the radius would be the square root of this value, which would be positive square root of 7. Not negative square root of 7 because, of course, a radius is the distance from the center to the edge of a circle. Distances are always positive, so we would say the radius would be positive square root of 7. This is called a quadratic linear system. Anytime we see the word system, that means we're talking about more than one equation, and this is a quadratic linear system because we have a quadratic equation and a linear equation. So it's a system that has a quadratic equation and a linear equation. It's called a quadratic linear system. This is parabolic, this is linear, and you can imagine a parabola and a line intersecting once or twice. So we can get more than one answer in these systems. Now, this problem is set up such that we could easily solve this second equation for y, and we would be left with y equals 2x plus 7. Now we could take this value and put it in here for y. Why would we want to do that? Well, because in both of these equations, we have two variables. You can't solve an equation with two variables in it, but you can solve an equation with one variable in it. So I'm going to use this method known as substitution. I'm going to substitute this in for y, and now the whole problem will be in terms of x. So when I do this substitution, I'm going to be left with this value, which is equal to y squared. So to me, when I look at this, I'm really seeing y. It is y. It says it's equal to y. Y squared, which is what this says, minus 2x squared equals 23. And again, caution here, we have to square a binomial. In fact, I encourage you to always write it out twice. When you don't, a lot of times you make a mistake. So I'm going to have a first, I'm going to have an outer, I'm going to have an inner, I'm going to have a last. This negative 2x squared is still part of that left-hand side. I can clean this up a little bit here. I'm going to have a, let's see, a 4x squared plus 28x plus 49 minus 2x squared. This is quadratic, so I want all the terms on the same side, so I'm going to subtract that 23 over. Lastly, I can combine some more terms here. The 4x squared minus the 2x squared will be 2x squared. I have a 28x. I also have another pair of like terms. I have a 49 minus 23. 49 minus 23 is 26. Well, each of these terms can be divided by a 2 on the left, so I'm going to divide everything on the left by 2. I also need to divide everything on the right by 2, which is just a 0. 0 divided by 2 is 0. But by doing so, I create a quadratic equation, which is much easier to factor. This is going to factor into x plus 13, x plus 1, and I can set each of these equal to 0. Remember, these are the x-coordinates of the 2 points where the line and the parabola intersect. This says to solve the system. Solving a system means to find the coordinates of each point. This is not a point. It's an x-coordinate of a point. This also is not a point. This is, I'm trying to point here, but it's not going to let me. This also is not a point. That's the x-coordinate of a point. These are the x-coordinates of the 2 points. We can't put them together to make a point. You need an x and a y. How can I find y? Well, I can substitute into one of the first two equations. I like this one, so I'm going to go ahead and put that x in there and solve for y. So I'm going to have y minus 26 equals 7. Oh, wait, it appears that I have a sign error here. This should be positive 26. I will subtract 26 from both sides. 7 minus 26 is negative 19. That means the first point of intersection between this parabola and line would be negative 13 comma negative 19. And also over here, I can plug in this x value. But I should have the right equation. So y minus 2x equals 7. So y minus negative 2 times negative 1 equals 7. Y plus 2 equals 7. Or y equals 5. Putting that x coordinate of negative 1 together with 5, I get the other point of intersection, negative 1, comma 5.